everyone, welcome back to Pepcoding. So the question which we will solve today is called find longest awesome substring. So what the question asks you to do is that you have been given a string, right? And the string is of numbers which range from 0 to 9. So what you have to do is that you have to figure out the longest substring which creates a palindrome, and the condition is that you can do any number of swaps on it, like you can do infinite number of swaps. Okay, so for example, if I take out this part of my string, okay, so for this substring that is 32424, what is happening is that I can see that this can make a palindrome. If I try to swap these two positions, I will end up getting 42324, and I know this is a palindrome, so I required to make one swap to have a palindrome or a substring of size 5, right? Similarly, if I take out this part of the substring, right, this part of the string, so 2424 and 1. So in this, if I swap these two positions, I will get 2 4 1 4 and 2, and this is again a palindrome. So you have to figure out the longest substring from within the string which has been given to you, and you have to figure out that what will be the length of the string given the fact that it should be a palindrome 1, and you can do infinite number of swaps on it to make it a palindrome. Okay, so that is your question. I hope you will be able to solve it. Please try to solve it, and then we will head into its solution. Okay, so now when we are talking about the solution, see, first thing which we need to talk about is what is the property of palindromes, right? So if I have a palindrome, so let's suppose if I have a number something like this, I know I can make a palindrome out of this, right? So 4 4 3 3 and 2 2. This will give me a palindrome, right? This is a palindrome. So I can see that over here, to make a palindrome, each digit came even number of times, right? I could have 4 number of times, right? I could have 4 number of times, and even then it would be a palindrome. So all digits should come even number of times. This is one. Second property, if I added another number, let's say 6 over here, one time, only one time, not even number of times. So if I put it right in the middle of my palindrome, let's say I put it over here, then also it is a palindrome, right? So we can say that another property is that all can be even except one, which should come only one time, right? So that will be the property of palindromes which we will have to follow, and on the basis of that only I will be able to solve the question. Okay, so for example, let's say over here, the concept which we will use will be of prefixes. Okay, so the prefix method we will be using. So let's say my string which I will take will be 3 4 2 4 2 4 and 1. Okay, so this is my string and I'm working on it, and over here I need to check at each position, right? Let's say over here I am taking a count, right? I need to figure out that which of these numbers is coming how many times. So over here, if I look at this position, 3 is coming odd number of times, rest are coming even number of times. Over here, 3 and 4 are coming odd number of times, rest is even number of times. Why are rest even number of times? Because we are taking the condition that any number, if it comes 0 number of times, it will be considered to be even number of times only. Okay, so over here, now similarly, if I check for the last position over here, so see, 3 is coming odd number of times, 4 is coming odd number of times, 2 is coming even number of times, and 1 is coming odd number of times. We had the conditions that either all can be even or 1 can be odd and rest of them should be even. Now over here I only have 1 as even, the rest are odd. So I need to do swaps, right? And I need to be able to make a condition, I need to be able to get a condition where I can have all of these as even only, right? I need to have a condition where I want all of these to be even only. So if I want that all of these should be even, then I will need a place or a position where 3 should be 4 odd, 4 should be odd, and 1 should also be odd, right? Because if I want to make even out of odd number, let's say out of 7 I need to create 6, then I need to subtract an odd number from it, right? So but if you look over here, you know that there is no position in the entire substring before this position where 1 will be odd, right? So it is not possible for me to make all 3 of them as odd. But that's not a problem, because we have a property where these 3 can be even and 1 can be odd, and even then our string can become a palindrome, right? So I will figure out a position where 3 will also be odd and 4 will also be odd. Now if I come over here, right, if I come over here, then I have 3 as odd but 4 as even. This cannot work. So I have 3 as odd, 4 as odd. This is correct. So if I deduct or remove this portion of my string from the entire string, if I remove this prefix, then I will be able to get 3 as even and 4 as even, right? And then this entire part of my string, that is this substring, will be able to become a palindrome, right? So I am only working with the length. I don't care about the swaps. So now let's try to understand this with another example. Okay, in fact, before that, I could do one thing else, right? There's another thing I could do with this. This was odd, this was odd. I could make these 3 as even and make this as odd, right? But the problem is I cannot make 1 as even. Let's suppose I had 1 somewhere over here and somewhere over here. Okay, now 1 is odd at this position also, and I can easily make it even, right? I can make it even. If I come at this position, then 3 is also odd, 4 is also odd, and 1 is also odd, right? So I can make this even. I want to make this as odd now, right? So if I make 2 as odd and change all these 3 to even, will I be able to get a palindromic string? Yes. See this position. If I take this position, 3 odd, 1 odd, 4 odd, and 2 odd. If I remove this part of my substring, I will get this, right? 4, 1, 2, 4 and 1. If I swap these two, I will get 4, 1, 2, 1, 4, and this is a palindrome. So I will get a palindromic substring. Now let's take another example. So I can take 2, 3, 4, 5, 4, 5 and 2. Okay, now over here if I check for this position, then 2 I have odd number of times, 3 I have odd number of times, 4 and 5 I have even number of times. Okay, so 4 and 5 will not create an issue. Now what I need to do is I need to make, I'm sorry, 1 second. I need to make either both of these as even or at least one of these as even. So let's say first condition is that I am making both of these as even. So in that case, I'll need to figure out I have to figure out a position where the configuration includes both 2 and 3 as odd. So if I come to this place, then 2 is also odd, 3 is also odd, and 4 and 5 are even. So this part removed from the string can give me a palindromic substring, right? So that would be one solution or one part of the solution. Another part of the solution which we have is that I can make either 2 as even or 3 as even. Now if I try to make 3 as even, then I need a situation where only 3 is odd, right? So if I come over here, then 2 is also odd, 3 is also odd. The problem is I did not want 2 to be odd in this place. So if I want to make only one of this as even, one of these as even, 3 will not be the option. So I can make 2 as even, right? So I will come to this position. 2 is odd and rest are even. So if I remove this from my entire thing, from my entire string, then this part of my string will be a palindrome. I'm only checking till this place, right? So this part will be a palindrome, right? Okay, now let's consider a situation. I'll just add a few more to this. I'll add 6 and 6 over here. Okay, so over here I have 6 also as even. I have 6 as even. So one thing was same. A few of the solutions would be same. First solution would be that I could have both of these as even, right? Or I could make 2 even, because 3 cannot be made even. Another solution which I can have is that if I make this as even, 4 and 5 are even, I make 6 as odd. That is also a solution, right? So if I make 6 as odd, for that what thing I need is that I want 2 to be odd, 3 to be odd, and 6 to be odd as well. So I will remove this part of the string, and this much of my substring will become the palindromic substring. We don't know whether it will be of maximum length or not, but we know that it will be palindromic. Okay. So over here, if we are working in this case, I had 2, 3, 6, 4, 5, 4, 5 and 2, right? Now one solution I have for this is to use hash maps. When I'll be using hash maps, I'll have to take for each position, and for each position I will keep the count, and then I will have to compare each position with the type of configuration that I want. So the complexity which I'll get will be O(n) square. We don't want to work with O(n) square. We definitely don't want O(n) square to be our complexity. So what we'll do is that we will use bits. How will we use bits is the question now. So see, in bits we can use 0 or 1. So I am going to assume that for me 0 means even number of times, 1 means odd number of times. So for example, if I take this case, then I want till 6, right? So I will have 6, 5, 4, 3, 2 and 1. Okay, so over here 6 is even number of times, 5 is even number of times, 4 is even number of times, 2 and 3 are odd number of times for this position, right? And 1 is not even available, so it is 0 number of times, and 0 is even, right? Also 0 is also not there, so it is even, right? So what am I going to do? I can make these two as odd. Oh sorry, these two are odd. I can make these two as even, right? So for that I will check these two, I will toggle them, and I will check for the previous configurations which will make these as even, right? Another solution I will have is to make 2 as even. We discussed why we cannot make 3 as even. So I will make 2 as even. For that I will toggle this, and I'll have to check for the previous configurations, right? Another solution will be to make both of these as even and to be making 6 as odd. That was also my solution. Or I could make 4 and 5 odd. That would be my choice. But if I make 6 as odd, then in that case I'll have to toggle all of these, and I will have to check a previous configuration, right? So this is what we are going to do, and for this I will use a hash map. A hash map I will be using. Just remove this, and in this I will have a number, and in front of it basically the state, and in front of that state the kind of configuration it has had, or the count it is having. I can store that. So that will work much easier for me, right? The complexity will be reduced, and I will work in a easier manner. So we have not discussed a lot of it, obviously. We need to discuss that part, but we will discuss it while we will be doing the coding part. Okay. Now see, we discussed that we will be taking a hash map. But the thing is that when we will work with a hash map, there might be a point that the complexity or the time which we will be taking will be a little too much. So to reduce that over here, what we can do is we can take a vector or an array. Okay. So I will take a vector of type int, name it map. Okay. And what will be the size? 1 left shift 10. Okay. And when we are working with this, see, first of all, why did I take a vector? We know that the bits when I am using, I have to take from 0 to 9, right? So over here, if I'll take this, then the worst situation that I can have is that all of these positions will have 1, right? That for all of these indexes, the bit will be 1. So I have to handle this. But this can easily be solved using array also, right? Why do we need a hash map to maintain this? So what we are going to do is, we are going to take a vector array, okay? And with this, I am going to work. So now when I am working with this array, the thing is that if I have a string, suppose 2, 2, then in this string, the bit which I'll get will be 0, 0, 0. Now, when I'll toggle this, it will look for a configuration and the configuration will be for 0. But it is not available. So what I'm going to do is I'm going to put by default at the 0th position -1. Okay. So over here I have map of 0 will be equal to -1. Then I'm going to traverse the string. So for int I is equal to 0, I is less than, let's just take out the length of the string. So int n will be s dot length. Okay. And over here I is less than n, I plus plus, and character char ch will be equal to s dot at I. Now see, this value which I've taken out, for this we need a state. Now if I have something like this and I want to make both of these as 0, to make the whole thing as even, I need to make both of these as 0. So for that, I'll have to toggle them. I'll have to search the position where I have 1, and that position has to be toggled. So for toggle, we use XOR, and we need to find out a mask, right? And we know how to work with mask. We know how to find out mask, right? So over here, I will have int mask will be equal to 1 left shift by ch, and since it is a character value, so I'll deduct or I'll subtract 0 char from it. And now I have a state which will be equal to 0. So now state will become state XOR mask, right? Then after that, after I'm done doing the toggle part, I need to figure out the previous configuration of that position. For example, if I have this position as I, and I need to figure out the previous configuration, so I have to find out in the map itself, that is in the vector, whether it is already present or not, right? So if it is present, let's suppose it is at the jth position. So I'm going to find out this jth position. Now I need to find out the length of it, right? This part has to be deducted. Between j and I, the length will be equal to I minus j plus 1, right? And since I have to remove this part and only have to take this part of the string in consideration, so this will be removed and our length will be I minus j. And since we need the maximum length, so we are going to maximize it. Okay. So over here I'll get int j from the map. So map of state will give me j. And if j is not null, then in that case, answer, which is my maximum length which I want, and that I'll initialize over here. So answer will become equal to maximum of answer and I minus j, right? Okay, then after this, I need to work for the odd bits. Like basically right now, I have made all of them as even, right? Now the next thing is that if I keep one of them as odd, so if I have something like this over here, I can either make both of these as even or keep one of these as odd, or make both of these as even, or make another one as odd, right? So for working with this, I will have to toggle each position. Let's suppose I have something like this over here. So I have 0, 0. Now these are all even. I need to make one of them as odd. So I will try for this position also, for this position also, for this position also, this position also, for all of them. And I will figure out the position for which I will get the maximum length of the substring. So I have to check for all the positions. So for int odd 0 to 10, right? 0 to 9 I need to range. So 0 to less than 10 and odd will be increased. Then after that, we will figure out a mask. We've already initialized mask. I'm not going to initialize it again. Mask will be equal to 1 left shift by odd, right? And now j will be equal to map of state XOR mask, right? So this will get me the previous configuration. And then I will take this part exactly the same, right? And I'm going to return answer from here. But there can be a situation where we will get the same state at multiple places, and that will cause an error, right? We will get the same state at multiple places, so we want the one which exists earlier. Basically, let's suppose two of these places, this and this place, has the same state. Okay, so in that case I need to make sure that I take this one, right? So I have to make sure that that state does not already exist in my map. If it already does exist, then what will I do? Over here I will check that if map of state already exists, then I'll do nothing. If it does not exist, that is if it is null, then I will put map of state as I. Okay, so one kind of state or one kind of configuration cannot exist multiple times. Okay, so this will be my final code. The thing is, I will not be able to run it for you because we are still working on the test cases. But we've already discussed the logic for the question, so I'm quite sure that you will be able to work on the code by yourself now. So, and pretty soon you will be able to run it on the portal, so that's nothing to worry about. So we will see each other in the next video. Keep practicing, and till then, please like, share, and subscribe to the channel. Thank you.